Okay, so let's start calculus 3 then. Ready, guys?
Yes, miss.
Yes, miss.
Whatever we have discussed so far, all are useful to understand these exercises. Okay, let's start with exercise 1. So it says that consider a function of two variables which is given by difference of two functions. One is an algebraic function which is given by square root of x plus 1. Remember, this is a function of x and y, even though y doesn't appear there. Okay, and this is also a function of x and y. So since there are two inputs, the dimension of the domain is 2. The dimension of the domain is 2. That means since inputs are denoted by x and y, so the domain will be the subset of the xy plane. Is that clear?
Yes,
Yes,
miss.
miss.
Okay, so now first there are two parts of the exercise. First part says that evaluate the function. Could you please evaluate this? Tell me whatever you get.
Root 1 minus 2.
Root 1 কি করে হচ্ছে বাবা? X,
Root 4.
what is x here?
3.
Oh, miss, 3 minus 1. I'm 0, 0 দেখছিলাম. Sorry.
X is
2
it's
minus
okay. It's okay. I asked you to give me the value of third one, if possible. If possible, give me the value.
Two minus log 2 minus 6.
That means 2 minus log of -6 base 2.
Yes, miss.
You get -6 here, right?
undefined.
If you plug in
Undefined.
3 for x and -1 for y, then you get 4 minus 10, which is -6. And the domain of log function cannot have -6 in it. So this is undefined, right? So this is undefined. Is that good?
Yes, ma'am.
Quickly, could you please give me
Yes,
the value of this?
Minus 1.
Miss, root 2 minus 1.
Root 2 minus
Yes, ma'am.
1.
Root 2 minus 1.
Square root of 2 minus 1.
Yes, ma'am.
Okay, very good. So here you go. This is square root of 2 minus 1. And this one is not defined. That means undefined, because -6 is not in the domain of the log function, period. Okay, now let's talk about the domain. So this is the function given. The function is the difference of two different functions. One is algebraic function, one is logarithmic function. So we have to find their domain, and then we have to take the intersection of their domains. Does it sound familiar, the statement?
Yes, miss. The subtraction form.
Yeah, subtraction. Very good. So let's take the domain of this function, square root. Since it's a square root, it's a radical of even index, and since it is in the numerator, so x plus 1 cannot be negative. X plus 1 should be either greater than or equal to 0. Is that good to everyone?
Yes, miss.
Yes, miss.
Class? Okay, now let's focus on the logarithmic function. We know that the domain of a log function, of any log, domain of logarithmic function is set of all positive numbers. All positive numbers means whatever the input is, doesn't matter what is the form of the input, that input must be positive. So the input is given as an equation here. So it doesn't care, we don't care what is x, what is y. We just need 4 minus x squared minus y squared to be positive. for any values of xy. Our requirement is we want 4 minus x square minus y square greater than 0 so that the log is defined. Is that clear?
Yes, miss.
Yes, miss.
So this is the domain of the square root function and this is the domain of the log function. So if you do the simplification, x is greater or equal to -1. Here you go. And if you do the simplification, we get x squared plus y squared less than 2 squared. Less than 4 means less than 2 squared. Then obviously you can ask me then why I'm not writing 4 is greater than x squared plus y squared, because we are trying to match with the form of equation of a circle x squared plus y squared equals to r squared. So we know that x squared plus y squared plus r squared is a circle, and that gives us points on a ring, right? The ring, which is around the center 0, 0 at the
Radius
distance
2.
2. This radius 2, exactly. And if I have the inequality, x squared plus y squared is less than r squared, that gives us all the points which are inside that ring, inside that circle. Since we do not have equality involved, that means the circle is not part of that set. Everything inside of the circle, but not any point
Excluding the-
on the circle. Is that clear to everyone?
I mean, excluding the
Yes,
circumference.
miss.
Excluding the circle, obviously. If I'm saying it, which is not here, but still I'm giving you the information so that I can give you, I can assign you some exercise. If you have greater means points outside the circle. Do you read me?
Yes, miss.
Yes,
X
miss.
squared plus y squared greater than r square means all the points which are outside the circle with center at the origin and radius r. So less than means inside the circle, equal means on the circle, greater means outside the circle. So now I have two inequalities. One is greater equals to -1, other one is x squared plus y squared less than 2 squared. Okay, so let's start with this. Let's start with this interior of the circle. Please take paper and pen and draw the circle. Guys, listen to me very carefully. To mean exclusion, since we are drawing, we have to sketch the domain. This is part of our work. We have to sketch the domain. So otherwise this domain is not clear. See, the domain of this function is this. This is the domain. This is the domain, and this is we don't have any clear visualization from that set. This is in set builder notation, and that is not clear to us. So to make it clear, we have to sketch it. Is that good?
Yes,
Yes,
ma'am.
miss.
Yes, miss.
So let's take paper and pen and draw the circle. Then we have only the interior. The circle is excluded. So if you want to exclude any boundary, that boundary should be drawn in dotted line. So draw the circle using dots. Just dot. Dot means dotted line means excluded. If you want to include the line, if you want to include some boundary, that boundary should be solid line to mean it is included. Did I make it clear to you?
Yes, miss.
Yes, ma'am.
And this circle is excluded because we don't have equality here. We don't have equal sign included here. So circle is excluded. So draw a dotted circle. Did you do that?
Yes, miss.
Okay, now let's take the other piece. So it says that the domain of the function is any ordered pair x comma y. That means any point in the xy plane that is inside the circle of radius 2 with center 0, 0. Inside the circle, not on the circle. Inside the circle, and those points should be to the right of this vertical line x equals to -1, because this one says that x equals to -1 or x is greater than -1. When you are looking for the greater numbers, they are sitting to the right. So equality is there. Do you see the equal sign, greater or equal? So x equals to -1. That is a vertical line, and that vertical line
Equation
is
parallel to
included.
Y.
Huh. That vertical line is included. So x equals to -1 is the solid line. Look at the graph. Draw that line inside the circle and make it a solid line so that you mean it included. Did you do that?
Yes, miss.
Yes, ma'am.
And if you want all the xy points which are inside this circle and to the right side of this vertical line x equals to 1, then you shaded that piece. That just shade the portion of the interior of the circle which is to the right side of the vertical line x equals to -1. So all the points on the line x equals to -1 inside the circle to the right of this vertical line. Do you see the domain? Do you understand it now?
Yes, miss.
Yes, miss.
So that's the domain. Question?
Greater than -1 and smaller than 2.
Not necessarily. If you say greater than -1 and smaller than 2, which variable is greater than -1 and smaller than 2? Which one you are talking about? Because you don't have a single variable. You have two variables
Both.
now.
Both. I mean, the both variables, including both variables, the domain is in the area -1 to 2.
No, because this is -2. Why is -2? So why is not between -1 and 2? Here y is -2. And if you say x is greater equals to -1 and less equals to 2, you mean two vertical line. X equals to -1, x equals to 2. Those are vertical line. Look at this right side boundary. You don't have this point which is between -1 and 2. This point has x value between -1 and 2, and this point is not in the domain. Definitely not. Even 2, 0 is not in the domain. Even 2, 0 is not in the domain. It's a circle. It's a curve. Don't forget that. You cannot make it that obvious.
Yes, miss, I understand.
Shall I move on then?
Yes, miss.
Okay, second exercise. So it is given as a function of three variables, x, y, z. That means domain will be three-dimensional. So if you try to evaluate this, you have values for these two, but this one is undefined. This one is undefined because you get 9 minus 10, which is the square root of -1. So the output will be I. That means imaginary. Okay. So to find the domain, since you have a single function, which is the square root, so this thing, it's in the numerator, so 0 is allowed. So this one should be greater or equal to 0. If you solve this, then you get this: x square plus y square plus z square less than equal to 9. That means x square plus y square plus z square less equals to 3 square. This is not a circle. This is a sphere, a ball. This is a sphere because this is three-dimensional. Circle is two-dimensional. So now you have a sphere. Just think of a ball that you play with. The surface, the leather surface of the ball is the equation. X square plus y square plus z square equals to 3 square. That is the radius of a ball. Radius, it's a ball. It's a ball, the surface of the ball of radius 3. And if you say less than 3 square means the wind that you have inside the ball. So the vacuum inside the ball.
Part of inside the ball.
Yeah, so you consider that piece as a solid piece, and each point is bubble in the wind is a point for that domain. So you have inside and surface. Okay, less means inside, equal means surface now, since we have a ball now, and greater means outside. Do you get that?
Yes, miss.
Since we are in 3 dimensions, so now we have 3 axes, x, y, and z. I will explain this to you on our next lecture. So here you go. So this is the ball. We mean it a ball since we can see three axes. Okay, so this surface and inside. just take it until here, then later I will give you more details. When we understand, when we will study the 3D space, then it will be more clear to you, okay?
Sure, Miss.
I want you to think about these 3 exercises. Just spend some time to think about them, okay? I will make them blue. I'm not going to talk to them. Okay. So do you have question, class? So far, are you doing good?
Yes, ma'am.
Yes, miss.
Yes, miss.
So let's see a definition. Let's see a definition. So this definition says that find the domain of the function, which is a composite function. If I want to find the domain is given by collection of all real number x. Look at this function. It's a single valued function. So it should be so that x should be input of g, so that g of x is the input of f. That's the requirement. X should be input of g, so that g of x is in the domain of f. G of x is in the domain of f. That's the requirement. Yep.
Miss, so we will find the domain of f of x, and then we will find the domain of g of x, and those values of g of x that belongs to f of x will be
the domain.
The required.
Exactly. Exactly. Is that good? Okay. Now look at the function. Look at the exercise 3. The function is given by a composition. Okay? Guys, there are 4 functions in the composition, but I will treat them as 2. This is one function for us. Okay? This is one function for us, and the other one is sine function. So could you please tell me the domain of the sine function?
All real numbers.
All real numbers, and that make our life easy. That means we just need to consider ordered pairs x comma y, so that this is real. That's it. If this fraction is real, sine will be taken by that. I'm sorry, that number will be taken by the sine, because sine takes everything, every real number. Is that good to you?
Yes, Miss.
Yes.
Class, I need your participation. This is very important to understand. We just make sure that this fraction is a real number. Remember, by real I mean defined, because real numbers are defined numbers. Okay? If I say defined, then I have to mention real, because all defined numbers are not real, because complex numbers are defined numbers as well. So real number, when I say real, I mean real, defined, and not complex. Okay? So we just need to have it real. That's it. Because sine will take any real number. So then I can conclude that domain of this composition is any x comma y ordered pair, so that this fraction is real. Can I? We will take any x comma y, so that this is real. If this is real, that will be taken by the sine. Is that good?
So we will not think about the denominator here. I mean, we don't need to find that x square minus y.
We will think everything. We will think everything. We didn't go in. We didn't discuss this fraction. We just mentioned what we need. We didn't discuss the fraction yet. When you will discuss the fraction, we will consider those things, definitely. First, let's get the outline. The outline is that since this is a composite function, composite functions means domain will be taken from this domain of this function, which should be in the domain of this function. And since this function has domain all real numbers, so we just need to say that the domain, this should be real. If this is real, then the x comma y must be in the domain of the function, and that's it. So that can be written, that can be summarized. Just summarize like that. Here you go. The domain of the function is this. See if you understand this. Plus, it will be any x comma y, so that this fraction is real. If this fraction is real, then definitely this is in the domain of sine function. Okay, now we will try to make sure, we will try to make reason when we get it real. Okay, real means it cannot be undefined, real means it cannot be imaginary. Now look at the fraction. So that fraction is real if the denominator is non-zero, and since we have the square root, x square minus y cannot be less than 0, x square minus y cannot be 0, x square minus y must be greater than 0. Do you understand that?
Yes, miss.
Yes.
miss.
Even
Yes, miss.
index.
So there you go. So this is the domain for this function. That means solve the inequality, then you have y is less than x squared. Again, you can ask me why I am not writing x squared is greater than y, because I am trying to get it in this format, y equals to function of x. Y equals to function of x. If this is y is less than x squared, or y equals to x squared, or y greater than squared. So I try to keep y on the left. That is the reason I have written it in that manner. Is that good to everyone?
Yes, miss.
Yes, miss.
So now we know that if y is less than x squared, then this is defined real number. So the domain is this. In place of this statement, I can say that y must be less than x squared. That's it. Because we found this inequality considering this, right?
Yes,
So that
miss.
this is the domain. So let's draw the domain. Let's sketch the domain. So first, graph the function y equals to x squared. Since y doesn't equal to x squared, so we have to draw the parabola y equals to x squared using dotted line. Do that, please. So here you go. Do you see the parabola?
Yes, miss. Are
Yes,
it two?
miss.
Okay, now miss, দেখা যাচ্ছে এখন. Yes,
Okay.
yes, perfect.
So this is the parabola. Now look at the parabola. This parabola is a dotted parabola. Make it very clear to your work, because this is not clear to me in my work. So your work should be more clear than mine. Okay. So this is dotted line. Okay. Now the question is, on this parabola, at each point on this parabola, y is square of x. That means take any point on that parabola, you get y equals to x squared. Y and x squared, they are equal. Now look at that vertical line. Look, do you see the vertical line I'm moving?
Yes, miss.
Yes, miss.
Yes, miss.
Just place it anywhere on the parabola. Let's say that I'm placing it here. Okay. Okay. Now, since this is a vertical line, on this line x is fixed. Since this is a vertical line, on this line x is fixed. So since x is fixed, x squared also fixed. Is that good?
Yes, miss.
Now at this point, do you see my position, the cursor on the parabola?
Yes, miss.
At this point, whatever x is there doesn't matter. At that point, y and x squared are equal, because that point is on the parabola y equals to x squared. Is it clear to you?
Yes, miss.
So whatever you have for x squared at this point, since you have the same x value on the vertical line, so you have the same x square on that, along that line you have same x square. But at this point, y and x square are equal. But if I go up, y is increasing. If I go down, y is decreasing. That means below parabola, y is less than x square, or above parabola, y is greater than x square. Our domain is y must be less than x square. So we are taking the portion of the plane which is outside of that parabola. We cannot take the inside portion. Do you understand that?
Miss, can you repeat it?
Sorry, come again?
Miss, can you repeat again?
Sure. So see, we are using a vertical line to understand the phenomena. So vertical line means I'm fixing x. Vertical line means x equals to constant. since x is constant, x is square also constant. Now move on move along the vertical line. The point which the vertical line intersects the parabola at some point. Doesn't matter where you place the vertical line, everywhere, because the domain of parabola is all real numbers. So at any position, the vertical line will intersect the parabola at a point. So at that point, y and x square are equal. If you go up, y gets bigger. If you go down, y gets smaller than x square. Because x is fixed, x squared is fixed. Moving along a vertical line, only y is changing. So y equals to x square, y is greater than x square, y is less than x square. So our domain is xy point, so that y is less than x square. So parabola is the boundary. Parabola is the line that divides the xy plane in 3 sets. One is y is less than x square, which is below the parabola, y equals to x square, which is the parabola itself, and y is greater than x square, which is the region which is inside the parabola. Do you understand that?
Yes, miss.
So our portion is y is less than x square, which is this portion. Is that clear?
The area after the intersection of that vertical line, I mean, the area after the intersection of the vertical line with that parabola, right?
No, forget about the vertical line. I can delete the vertical line. I don't care about the vertical line. The domain is below the parabola. Everything under the parabola. Everything. I mean, extend the parabola is spread from negative infinity to positive infinity. It's opening upward. So it has a lower portion, right? Since it's opening upward, so each point has a parabola is the boundary, and there is some portion of the plane underneath the parabola. That portion is in the domain.
Okay, miss.
Is that clear?
Yes, miss.
Okay. So understanding this graph, can you quickly give me the domain of this function? Now, instead of square root, you have 9th root.
Ma'am,
X square is not equals to.
yeah, xy can't be equal to y. Other than that, all real numbers.
Not all real numbers. Everything from the xy plane. Xy plane is not a number. Xy plane is an ordered pair. Remember, 2-dimensional. When you say number, you mean 1-dimensional. Domain must be 2-dimensional. So you should be careful about what you are saying. Okay. So yes.
That's why we have the
everything of the xy plane except, continue Hamza, except
y equals x squared.
Except the line which is given by the equation y equals to x squared.
Yes.
That means inside the parabola, outside the parabola, but not any point on the parabola.
Miss,
is that clear to everyone?
Miss, is it possible for you to draw that figure?
Exactly. You do it. Just draw this parabola. Just draw this parabola with using dotted line. Shade inside the shade the region which is inside the parabola. Shade the region which is outside the parabola. That's it. Everything just except the parabola. So just draw the parabola using dotted line. You are done. You are done. You mean dotted means excluded. Dotted means excluded. When you draw the parabola using dotted line, that means that line is excluded and everything else is in the domain. Is that good?
So, miss, when there will be an odd number in the index, we will only take the denominator not equals to 0, right?
If it is in the denominator. If it is in the denominator, then not equal to 0. Yep. Let's say that I make it even to answer your question. Let's make another function. Let's make another function. For example, let's say that this is part B. Let's say that this is part B, and I am now giving it odd integer. But of course, let me copy the denominator and let me paste it here. So what is the domain of this function now? What do you think?
Miss, x square minus y greater than 0.
Mm-mm,
Oh, Miss, all real numbers. Sorry, Miss, all real numbers.
mm-mm. You are on right track, but how you said it, it's wrong.
Domain is a set of all real numbers.
No, all real number means one dimensional.
Oh,
You have to give me two
in the x
dimensional.
Okay.
The whole xy plane. So as I said, you said it correct, but you forgot the dimension. Okay, so you were partially correct. So okay, guys, I'm done for today, but you have to submit this exercise now. Find the domain, sketch the domain, and submit it, please.
Miss, where will we submit it?
I will give you 10 minutes. I will help you. I will help you. There are three functions, guys. There are three functions. One is fourth root. One is exponential function composed with cube root, and other one is natural log. So I will help you with the third one. Could you please help me with what is the domain of exponential function, by the way?
I'm all positive.
If you consider it as a function of two variables, then the whole xy plane. X can be anything, y can be anything. Exponential function for single variable domain is all real number, not positive real number. That's the range. Domain is all real numbers. So the domain is this, even for the cube root, if you consider this as a function of only the exponent I'm talking about, if you consider this as a function of two variables, x comma y, since you have cube root, odd index, that means domain is the whole xy plane. That means this function does not change. This function does not change the domain. What does it mean? What does it mean? The domain of this function is same as the domain of this function. Do you understand me? Because if you take the intersection with the set of whole xy plane, that doesn't change the intersection. Do you understand me?
Miss, I didn't get you. Sorry.
You didn't get which point?
Miss, the thing that you just said.
Because the domain of this function is the whole xy plane. Domain of domain of exponential function, domain of basic exponential function as a function of two variables. To mean the single variable now, if you take the exponential function as a single variable, domain is all real numbers. If you take exponential function with here is the restriction is that the domain of this is any real domain is all real numbers for y. All real numbers for y. X doesn't show there. That means x can be anything. That means you can take anything from the xy plane. X can be anything, y can be anything because it's cube root. So this one is the exponent of the exponential function. When you have the exponential function, domain of exponential function is all real numbers as a single variable function. So you can take anything for x and y. Since this is a real number, so this will allow you anything. So this allow any xy point from the xy plane. So that doesn't change the domain. So your work is to consider other two functions, find the domain, sketch it, and submit it. I will open the portal. I will give you 10 minutes. I will take your attendance. Please do that exercise and submit it. 10 minutes, please. So I'll give you 5 until 6:10. Is that good? 6 p.m. It is 5:50 now. 6 p.m. is good to you? Plus?
Okay, okay.
ম্যাম ভুল হইলেও তো সমস্যা নাই।
It is worth 1 point. ভুল হইলে সমস্যা আছে। But if you're partially correct, you will get the whole point. You will get 1 if you are partially correct. Okay?
Okay, ma'am.
that we need to notice today is, do you see this picture?
Yes, miss.
Yes, miss.
So today we are going to see how to, at least we are going to try how we are going to understand the 3D space, and we are going to try to graph functions. Okay, so to understand the 3D space, the XYZ space, we need to understand the scenarios, to the fact that what happens when three planes intersect each other perpendicularly. Then what happens? Do you see these two planes? One is green, one is blue. Do you see these two planes? Are you following the cursor?
Yes, miss.
Yes, ma'am.
So if these two planes intersect each other perpendicularly, then how many corners, how many sectors do we get at the intersection?
And 3.
Mm-mm. 3. Are you sure it's 3? Isn't it 4? 1, 1,
4, ma'am.
2, 3, 4. Right?
Yes, ma'am.
And what is the set of intersection between this? What are the set of common points between these two planes? If two planes intersect each other perpendicularly, the intersection is the set of intersections is a what? A straight line, right? Am I loud and clear in class?
Yes.
Yes, miss, but some surrounding sounds are appearing. So
The adjacent building, in that building, construction is going on, and it's really loud and annoying. I do understand. But am I clear? Shall I be a bit loud? Let's speak a bit louder so that my voice dominates theirs. Okay? Am I loud and clear now?
yes, miss.
Okay then. So the question, I repeat the question. I said, if two planes intersect each other perpendicularly, then the set of all points of intersection is it a single point, finitely many point, infinitely many point? What would be the intersection? That was my question. What do you feel? What should be the intersection? Isn't it a straight line?
Miss, many points.
Infinite many points. The set gives us the set of common points give us a straight line. Is that good?
Yes, miss.
Do you agree with that?
Yes, miss.
And we get 4 sectors. That means 4 sections, 4 corners at the intersection, right? Are you good?
Yes, miss. Yes, miss.
Okay. So now, if we talk about, follow the cursor. If we talk about this green and this blue planes, then this green plane is denoted by XZ. This green plane is denoted by XZ, and this blue one is denoted by YZ, and the line which is the intersection, which is the common line of these two planes, is denoted by the Z axis. Is this clear to everyone?
Yes.
Yes, miss.
Yes, miss.
Very good. Now let's insert another plane through the middle of those two planes perpendicularly, which is the horizontal plane. Look at these two planes, the 2 planes that we were talking about. Those 2 planes are vertical planes. They are perpendicular to horizontal plane, right? So if it consider this CN plane, do you see the XY plane?
Yes, ma'am.
হ্যাঁ মিস
Now this is the horizontal plane, which is the XY plane. Now how many corners we have at the intersection?
মিস 4
Four above the XY plane, other 4 below the XY plane, right?
yes miss
So total
8
8 corners, right? Now how many points are common to those 3 planes? That means now if 3 planes are perpendicular and they intersect each other, what should be the set of intersection? How many points does the set of intersection points
1
has?
point
Only a single point, right?
yes yes
That
miss.
point is the origin. Do you understand that?
yes miss
Okay, now let's separately consider pair of planes. For example, we have already seen that XY and YZ, they intersect each other perpendicularly through the Z axis. They intersect each other at the Z axis. If you consider XZ and XY, YZ and XY, XY, they have the common alphabet, which is Y. So the line where they intersect any two plane, if they intersect, then they intersect through a line. They intersect each other at some through some line, a straight line. And the straight line, when you have XY plane and YZ plane, that line is denoted by Y axis.
y
When you have XZ and YZ, the intersection is Z axis. When you have XZ and XY, then the intersection is X axis. Do you understand this?
Yes, ma'am.
Yes, miss.
Okay. And when 3 planes intersect each other perpendicularly, then we get 8 sectors, 8 corners at the common point, which is the origin. 4 above the horizontal plane, another 4 below the horizontal plane. And those 8 corners has a room. You can say that each corner can be considered as a room only with 2 boundary and the ceiling, or 2 wall and the floor. Do you understand that? If you consider those
Yes,
4
miss.
sectors, if you consider those 4 sectors under the horizontal plane, they don't have a floor, they have only ceiling. If you consider those 4 sectors above the horizontal plane, then they do not have a ceiling, they just have floors. Do you understand this?
yes
Yeah.
miss
Those 8 sectors, those 8 corners are called octant. So there are 8 octants. The octants are rooms that are created when 3 planes intersect each other perpendicularly. Then they create 8 rooms, 4 rooms above the XY plane, which is the horizontal plane, other 4 rooms below the XY plane. And those 8 rooms are called octant. And by rooms, we mean that those are sectors which created at the corner, create the corners which has 2 walls and either a floor or a ceiling. They don't have floor and ceiling both. Either it has floor, the room, it has 2 walls, and either it has floor or it has a ceiling. It doesn't have both. Do you understand that?
yes miss
Class, do you understand that?
Yes, ma'am.
Yes,
All
miss.
of us. All of us, right?
Yes,
Is this
ma'am.
okay? Very good. So those 8 rooms are called octants. Okay, so there are 8 octants. Is it good to everyone? Can you see this picture now clearly?
Yes,
miss
miss.
yes miss
আরেকটু কিছু বলতে চাচ্ছিলে, is there any problem?
No, miss, আমি জুম করেছি।
Okay. Okay then. So now next thing is that we need to understand the distance. Okay guys, now if you sorry, what I have just done. Okay, now it's good. Okay, so now I believe it's clear it's readable from your side. I believe so. Now we need to understand. So we understood that there are 8 octants. Okay, now we are going to, since these 8 rooms all together, all those 8 rooms together gives us the concept of XYZ space, the 3D space. So now we need to understand how do we study a point on that, a member on that is 3D space. If we have something in that space, how do you understand that? Now look at this thing. Could you please look at the corner of your room, the room where you are sitting? Are you good,
Yes,
guys?
miss.
Yes, miss.
Yes.
Now look at any corner. Look at any corner. At that corner, just be a bit creative. Just think that the corner is created by 2 vertical walls, right?
Yes, miss. Yes, miss.
Okay. Now extend those walls. If you extend those walls, then you have 4 rooms where you are sitting. If you consider the floor as the horizontal plane, as the XY plane, remember XY plane is always the horizontal plane for us because we are really comfortable to work on XY plane. We have done this up until now, right? So XY plane is the horizontal plane for now, of course, not always, for now. So the floor where you are sitting, that one is the XY plane. Extend it. Then just at the corner, consider 4 rooms on the floor and 4 rooms under the floor. Can you imagine that?
Yes, miss.
Guys, are you good with that?
Yes, ma'am.
Now look at the line.
Ma'am, can you please repeat that again?
Okay, look at any corner of the room that you are sitting in. Then that corner is created by 2 vertical planes and 1 horizontal plane. Just imagine, just extend those 3 planes. Don't just limit it to the corner. Just extend it beyond the corner. All 3 planes, extend it beyond the corner. Okay, then the corner, if you just think about the boundary line, then you have a perpendicular intersection, which is the Z axis. Just other 2 are on with the floor. Other 2 border lines are with the floor. So now guys, come back to the computer. Think that this is the corner you are looking at. Do you follow the cursor?
Yes, miss.
Yes, miss.
You are sitting somewhere in this room, and this is the corner you are looking at. This is the border that's created by the intersection of those two vertical planes. So this is the Z axis. If you extend this plane beyond your floor, so this under the horizontal plane, the portion of the Z axis, this piece gives you, which you don't see, by the way, okay? So that portion is the negative Z axis. Do you imagine now?
Below the floor.
Yes, miss.
Underneath the floor.
Yes, miss.
Yeah, which is underneath the floor. Yes, which is underneath the floor. That portion is the negative Z axis. That means Z values at that point, at that part of the axis is negative. Now, so this is the vertical boundary. Now you have other 2 boundaries at the corner, right? This border is 1 vertical plane and the horizontal plane, created by this vertical plane and the horizontal plane. Do you follow this corner?
Yes. I mean, Z
Yes,
positive and
yes.
Y positive. The space
Z
created
band.
by Z positive and
Yes,
Y positive.
yeah. Consider that this portion is the positive Y axis portion. That means that means on that portion y is positive, and definitely on this portion, then this portion, this on that wall, this portion of the plane, on this portion y and z both are positive. Do you understand that? And if we
Yes, ma'am.
extend that border, if we extend that border beyond the intersection, the corner which is the origin, if you imagine that border is beyond that corner, then this portion of the which is the extended line of this boundary, then this one is the negative y-axis. Do you understand that? Can you imagine this portion?
Yes, miss.
This is not in your room.
Maybe the space in other room.
Yeah, this is not in your room. This is in the adjacent room, right?
Yes, miss.
In the other room. Very good. Now look at the other border, because the corner is created by 3 borders, right? This one is the intersection of the second vertical plane and the horizontal plane. You have 2 vertical planes, right? So the other vertical plane and the horizontal plane created this border. Think that this portion is the positive x-axis. So if we extend that corner beyond the origin, then that other portion is negative x-axis. Then the room you are sitting in that room, if you just let a balloon flow in the wind, the position of the balloon, if you consider that balloon as a point, then x, y, z, all 3 coordinates for the location of that balloon is positive. Do you understand that?
Yes, miss.
Miss,
Basic
any
but
balloon
tabs.
flying in this room?
Yeah, any balloon flying in that room where you are sitting, because this is the room you are sitting in. Yeah, other 4 rooms are underneath the floor. The 4 rooms you are talking about, those 4 rooms have floor only. They don't have ceiling. They have floor only. Other 4 rooms are underneath the plane, where they have only ceiling. They don't have floor. So in these 4 rooms, in the room we are talking about, this 4 room. In this 4 room, you have only floor, and in the room you are sitting in, you have considered these 3 axes are positive portion of those axes. So all the points have x, y, z positive in the air of your room. In the air of your room, there are we don't see it, but there are infinitely dust particles. Each dust particle can be a point, and each location of that dust particle is given by x, y, z, where x, y, z all 3 are positive. And this octant is called the first octant, octant 1, first octant. Do you understand this?
Yes, miss.
Now look at the picture. Let's say that we are in this room. Guys, think that we are in this room. If we are in this room, if this room has positive z-axis, positive y-axis, but negative x-axis. That means in this room, if we have anything in the air of this room, then x is negative, y is positive, z is negative. Do you understand? Z is positive. Do you understand that?
Yes, miss.
Yes, miss.
So now I am going to ask a question for you guys. If you go under the horizontal plane, if you go to the room which is under this room, just under this room, what should be the sign of x, y, z?
X negative, y positive, and z negative.
X negative, y positive, z negative.
Z negative.
Plus, do you understand that?
Yes, miss. Yes, miss.
Yes, ma'am.
Very good. Come back to this colorful XYZ space. Now we are in this room. We are, remember, we don't see this border. Remember, we don't see this border. For us, this red portion is the floor. Do you understand this? This red portion is floor of your room. So this is the positive x-axis, this is the positive z-axis, and this is the positive y-axis, and you are sitting at some point of this red floor. Do you understand that?
Yes, miss.
Now I am going beyond this. I am going beyond this green plane. Do you see this green plane, exact plane? So when I go beyond that plane, that means y is negative. Do you understand that? Because this portion is positive. The y values are positive on this portion. So if I this is a vertical plane which is in green color. So if I go beyond this plane, then this portion of the y-axis we have negative y, right?
Yes,
Y
miss.
negative, X positive,
X positive.
and
Y
Z
negative.
negative.
Yes.
X
Z
So
positive and Z
now
negative.
if I'm in this room, if I'm in this octant, can you give me the sign of XYZ?
Miss X
A
positive,
Y
Z
positive,
negative,
Y negative, X positive,
Y
Z
negative.
negative. Y negative,
Class,
yeah, X positive,
class,
Z
did
negative.
you understand this phenomena?
Yes, miss.
Very good. Very good. So now let's conclude then. So in the XYZ space, every point is denoted by a triple, which is X comma Y comma Z. X is the sign distance from YZ plane. That means distance of the point from YZ plane. Now which portion? So that this is the YZ plane, the blue plane is the YZ plane. If you are on this portion, then the distance is positive. If you go in this location, in this position, we mean that the front portion has the positive X values. Front of this XY plane, YZ plane, which is the blue plane, any point which is at the front portion has positive X. If you go beyond behind the blue plane, then any point behind the blue plane has negative x coordinate. The distance will be given by x with a negative sign if it is behind the plane. If it is at the front side, then the distance will be given by a positive sign. That is what it means by the sign distance. Do you understand this?
Yes, miss.
So y is the sign distance to the sign distance of a point from the xz plane, and z is the sign distance from the yz plane. Is this clear to everyone?
Yes, miss.
So what is the distance of a point which is, just keep a ball on your floor. Keep a ball on the floor of your room. And your floor is the xy plane because your floor is the horizontal plane. So what will be the distance of the ball from the horizontal plane?
Positive Z.
The ball is
Positive Y. Positive Y.
on the floor. I repeat, let me repeat it. The ball is on the floor. That means the ball is touching the floor. So what should be the distance of the ball from the xy plane?
0.
0.
Z
And
0.
the distance, exactly, since the distance from the xy plane is denoted by the z coordinate, so z is 0 on the xy plane. Now talk about on, above, below. When you have horizontal plane, then on, above, below. So if you have something on the plane, then the distance is 0. So for z, if you have some point above the plane, distance is positive.
Z positive.
Exactly. If you have some point which is below the horizontal plane, then z is negative. If you have something on the xy plane, z is 0. Do you understand this?
Yes, ma'am.
Yes, miss.
Okay, very good. So now if I talk about something which is on the YZ plane, what do you understand then? Something on the YZ plane.
X0.
X is 0.
X must be 0. Something on the XZ plane.
Y0.
Y equals to 0.
Y equals to 0. Very good. So let's continue then. So next portion is here. Next portion is here. There are 8 octants in the XYZ space. In the first octant, everything will be positive. These are 0. X, Y, Z are 0 on the axis. X and Y are 0 on the Z axis. Y and Z are 0 on the X axis. And X and Z are 0 on the Y axis. Did you follow me? If
Yes.
some point is on the x-axis, that means x-axis is the common portion of xz and xy plane. xz and xy plane. So if something is on the x-axis, that point is on the xy plane and on the xz plane. That means on the xy plane means that if distance from xy plane it is 0. On the xz planes means the distance from xz plane is 0. Distance from xz plane means y0, and
Y0.
distance from xy plane means z0. That means if you have something on the x-axis, other two variable has 0 coordinate on the x-axis. If you have something on the y-axis, other coordinates are 0 on the y-axis. If you have something on the z-axis, some point, any point on the z-axis, x and y coordinates are 0, because z-axis is the common portion of zx and zy plane. Do you understand that?
Yes, miss.
Yes, miss.
Okay, so if you take the first octant with the coordinate planes, of course, because coordinate otherwise x is 0 on the yz plane, so you have to include the plane for the octant, otherwise you don't get equality. For the equality they are 0 only on the planes. If they are if they are in the wind, floating in the wind without touching any plane, then they are strictly positive if they are in the first octant. Do you understand that?
Yes, miss.
Very good. So now look at this thing. We have taken a point. This is this blue portion. This blue plane is the xy plane. This blue plane is the xy plane. So this is again in your room a balloon that is floating in the air in your room. So if the height of the balloon from the floor is 5 units, then look at this thing. Distance of that point from x-axis is 4. Distance of the point from y-axis is 3. That means x is 3, y is 4, and since the height of the balloon is 5, so you have the coordinate 3, 4, 5. Do you understand?
Miss, distance from
Yes,
y-axis
miss.
is?
This if you are in the xy plane, just think about the two-dimensional space, xy plane. Distance of a point from x-axis is the y coordinate, and distance of the point from the y-axis is the x coordinate. So look at the picture. Distance from the y-axis is 3. Distance from the x-axis is 4. That means y is 4, x is 3, y is 4, and this red pole, that one has the height 5. So this blue ball, the location of this blue ball in 3D space is 3, 4, 5. All good?
Yes, miss.
Now, in the last picture, there is another red ball. There is another red ball. By the dotted line, it means that this is under the horizontal plane. By dotted line, it means that this is under the horizontal plane. And since this portion has positive x-axis, that means if you go beyond the origin, that means this portion of x-axis gives you negative x values, right? So look at the location. It goes 2 units on the x-axis, 2 units away from the origin. That means x should be, since it's behind this plane, that means x should be negative, and the distance is 2, so x value is -2. Since the point y value is taken from the positive y-axis, so 3 units away from this point, the origin, that means y should be +3. And since it's 1 unit, look at the z-axis, 1 unit under the xy plane, so z should be -1. So this ball is given, the location of this ball is given by -2, 3, -1. Do you understand this as well?
Yes, miss.
Yes, miss.
Class, please focus. This is not easy thing, because when you will be working, then you will get confused. Again, if I get back to xy plane, can you tell me the equation of the x-axis?
Y equals to 0.
Y equals to 0. Very good. Now let's move to the three dimension. We have already discussed, if we have any point on the XY plane, what should be the location of that point?
Z equals
What
to
should be
0.
the Z value of that point?
0.
Z equals to 0. Doesn't matter at which position on the, at which location on the XY plane the ball is. At any location, for every location, if the point is just on the XY plane, then Z is 0. That means if I want to denote the equation of the XY plane, I can denote it by Z equals to 0, because that's the common thing for each and every point. Do you understand that?
Yes, miss.
So there you go. There we go. This is the only common point to those three planes. The only thing common to all these three planes, right? Otherwise, if you consider two planes, then they share a common straight line, which is a axis, could be between XY and YZ. XY, YZ, Y-axis is the common straight line between them. But if you consider three planes, then only one point is common to them, which is the origin denoted by 0, 0, 0, because since this is common point to each plane, that means distance of that point from each plane is 0. Make sense?
Yes.
So now x equals to 0, x must be 0 at any point. X must be 0 if it is on the YZ plane. That means equation of the YZ plane is x equals to 0. For any point on the XZ plane, that means equation of the XZ plane is y equals to 0. Z must be 0 for any point on the XY plane. So the equation of the XY plane is Z equals to 0. All good?
Yes, miss.
Since x-axis is the common line between the planes XZ and XY. XZ and XY. So Z and Y must be 0 on the x-axis. Z and Y must be 0 on the x-axis. X and Z must be 0 on the y-axis. X and Y must be 0 on the z-axis. Is that good to everyone?
Yes, miss.
Yes, miss.
Okay, so let's move forward. The next thing is that if you consider two dimension, now look at this thing. In 2D, if I say y equals to c, sorry, Baba, what didn't, don't you see that line? Was there any problem?
Miss. 2D.
Yeah, what did you say? It didn't come? You didn't bolle je eta ashe nai.
এখন এসেছে।
Okay. Okay, let's say that this is what you have. So if you have something like that, this means in 2D, this means that y equals to c is a horizontal line. And this is perpendicular. This is perpendicular to the x-axis, right?
Yes.
I said it wrong. Y equals to c is perpendicular to y-axis. Is it good to everyone?
Yes, miss.
Now, when you are in 3D, this will give us, instead of giving us line, this will give us plane. This will give us plane. So now let's see the conclusion for 3D space. Okay. So is it is the front big enough to read from your side?
Yes, ma'am.
Okay.
Yes, miss.
Now we are talking about planes that are parallel to coordinate planes. Let's say that if we take z equals to c, z equals to c means this is a plane. This is a plane which is parallel to the horizontal plane, which is the xy plane. Because z equals to c means Z equals to C means X and Y can be anything. X can be negative infinity from anything from negative infinity to positive infinity. Y can be anything from negative infinity to positive infinity. And this condition gives us the whole XY plane, but Z must be C. Z must be C. That means the whole XY plane, if C is positive, then the plane must be lifted C units from the XY plane, or if C is negative, then it will be moved down the XY plane C units. And if C is 0, then this is the XY plane, which Z equals to 0 is the equation of the XY plane. Do you understand that part?
Yes,
Miss, I'm not getting the figure that is drawn here about the
Okay.
means parallel to XY plane.
This is just take a line. Just take a line which is parallel to the, if this is the y-axis, just draw a line that is parallel to the y-axis. Then you try to write a plane, which for this plane, this portion will be, this is the dotted portion. This is the dotted portion, because this portion of the plane, since I have drawn it using in intersecting shapes, this is not very clear. I agree with you. I agree with you. For example, look at the second image. This image is much more clear because this is drawn. But this is just, I intersected a rectangle. I intersected a shape which is in rectangular shape, just to mean that how it may look like. You should notice that this portion of the plane is visible, and when it goes beyond these vertical planes, then those should be dotted portion. Those portions should be dotted portion. This portion will be dotted. Do you understand this? Or what can you do? You can just extend this. You can just extend the axis, lowering the plane. That means making it larger. If you make it larger, then you can just make this dotted portion of the y-axis to mean that you don't see that portion of the y-axis. Do you understand this? So it's your way how you are going to represent it. But yeah, something see that this is a line which is perpendicular to y-axis, because it is given by y equals to c. So perpendicular to y-axis goes through the point 0, c, 0, and this is parallel to the, since it is perpendicular to y-axis, so this must be parallel to the xz plane. Parallel to the xz planes, because it is perpendicular to y-axis. Look at the dotted portion. It makes it, the dotted line makes it clear when you draw it, which I don't have. I don't have the opportunity when I insert shapes. I don't have the opportunity to show the dotted portion. Do you understand that? Just try to make sure that you have. You just try to make sure that you have a plane which looks horizontal to you. All good?
Yes, yes.
Same for the other one. Same for this. Even this is not clear to us, because we have drawn the plane where this portion is visible and this portion must be under the plane. This portion must be under the plane. That means this marked portion must have dotted line. Do you understand this?
মিস মানে রেক্ট্যাঙ্গেলের ভিতরে যে মার্কটা দেওয়া মিস ওটা থাকবে না, তাই না?
This line, this doesn't bother us. This doesn't bother us. You can erase it or anything. This doesn't bother us. So another thing is how you're going to draw it. Do you want to mean that this is the vertical line perpendicular to this point and this portion is under the plane? If you want to mean that this portion goes under the xy axis, beyond the xy axis, then this portion should be, this one should be dotted, this portion should be dotted, and this one also dotted portion. You don't see this portion. So this is the this is above the, so you are cutting it. Do you see that you are cutting it like this way? So this portion is visible and the other portion is not visible. It goes beyond the xy axis.
মিস এই মিস এই 3D ফিগারের নিচেও তো মিস একটা এক্সিস আছে না, জেড এক্সিসটা নাকি নেগেটিভ জেড এক্সিস একটা আছে না মিস? এই
negative z axis is there. Definitely we have portion of the z axis there. Yes, we have portion of z axis,
but ওটা তো ফিগারে দেখা যাচ্ছে না.
Yeah, because we don't draw that portion. There you go.
ও হ্যাঁ মিস এখন হ্যাঁ
Definitely we have portion of z-axis. Not only z, we have portion of x-axis and y-axis. This is the portion of z-axis which is under the xy plane. Okay.
yes miss.
Okay then. So let's continue. So now let's say that we are going to graph the plane which is x plus y plus z equals to 1. All good?
Yes miss.
Look at the equation. The origin must not be on the plane, right? If x, y, and z, all three of them are 0, then you get 0 equals to 1. So origin is not on that plane. Is that good?
Yes, miss.
Yes, miss.
Now the question is, how do we draw the plane? Let's try to graph portion of the plane which is in the first octant. Let's try to graph the plane, the portion of the plane which is in the first octant. In the first octant, x, y, z, all three of them are positive. Okay, so let's try to graph the portion which is in the first octant. So let's take projection. You can do it by taking projection. So let's say that if we move to on the x-axis, y and z both are 0. On the x-axis, y and z both are 0. If y, z both are 0, then plug in 0 for y and z, then you get x equals to 1. And that means the point on the x-axis is given by 1, 0, 0. So the plane intersect whatever plane we have, the plane denoted by x plus y plus z equals to 1. This plane intersects the x-axis at the point 1, 0, 0. Is that clear to everyone?
Yes miss.
Class?
মিস তখনই বললেন না মিস যে y আর z 0 হবে অলওয়েজ x axis এ?
Yep. Always. X and z are 0 on the y-axis, always. So on the y-axis, x equals to 0, z equals to 0. So x equals to 0, z equals to 0. By solving, you get y equals to 1. So the plane intersects the y-axis at the point 0, 1, 0. Is that good to everyone?
Yes miss.
Yes, miss.
Similarly, the plane intersects the z-axis at the point 0, 0, 1. Is that good to everyone?
X and y is 0.
Yep, x and y are 0. So x, y, 0 means z equals to 1. Now think of a plane. Now think of a plane which is intersecting the x-axis at the point 1, 0, 0. Y-axis at the point 0, 1, 0, and z-axis at the point 0, 0, 1. Now we have got those 3 points considering only axis. If you consider plane for the xy plane, equation of the xy plane means what? Z equals to 0. And if you plug in z equals to 0, then you have x plus y equals to 1. And x plus y equals to 1, if you consider this equation of 2 variables which has a graph which is a straight line on the xy plane, the x-intercept is 1 and y-intercept is 1. So if you are on the xy plane only, then you have these straight line. And it goes beyond the plane, beyond the xz plane, beyond the yz plane, beyond the xy plane. That means underneath the xy plane. But we are just trying to look the portion of the plane which is in the first octant clearly. Because, yeah.
Miss x আর y axis থেকে same distance 1 এ আছে তাই না? মানে 1 ইউনিট ডিসটেন্সে আছে না x আর y axis এ? এই ফার্স্ট অক্টেটে যেটা আঁকলাম আমরা প্রথমে xy প্লেনের এই লাইনটা
exactly this distance and this distance, these 2 distances are equal. Yep, 1 unit. But since you are looking at some corner from some angle, it may look a bit different. Okay, Do you understand that? This is 1, 0, 0. That means the distance from this point is 1. This is 0, 1, 0. So distance of this point from this origin is 1. Even this is 1. All good?
Yes, miss.
Yes.
And this plane is YZ plane. This plane is YZ plane, and on the YZ plane, x is 0. So if you set x equals to 0, then you get y plus z equals to 1. And this is a straight line on the YZ plane, which is going through these 2 points. All fair?
Miss, z equals to 1 minus x minus y. Miss, এটা কোথা থেকে আসলো?
From here. This is portion of this plane which is visible from the first octant. You cannot be in 8 octants at the same time. So you are sitting in the first octant. You are sitting in the room that is considered as first octant. So you are trying to see portion of the plane which is visible in the first octant, but the equation of the plane is given by x plus y plus z equals to 1. And now if you want to write this plane as a function, let's say that z equals to f of xy, then it becomes z equals to 1 minus x minus y, right?
Yes, miss.
So it means that this plane, this blue portion, the triangular shaped plane, this plane is denoted by this equation z equals to 1 minus x minus y. But this is not limited to first octant, but in the first octant, this is the portion of the plane, and you can go beyond this zx plane. Just extend this beyond the zx plane, extend this beneath the xy plane, extend this beyond the yz plane to extend the plane. But this is the portion that you see from the first octant. Is that clear?
Miss, তাহলে x equals to 1 minus y minus z, এটা কোনটা মিস? যদি আমরা লিখতাম যে x equals to 1 minus y minus z,
that's the same one. This is the same one. This is the same one. Look at the equation. Doesn't matter. You consider x as the output, or y as the output, or z as the output. You get the same plane. By default, we have taken z as the output, because if you have function of 2 variables, you write it z equals to f of xy. So you have considered z as the output and xy as inputs. So then this is the presentation. If you decide to take x as the output, since it's a linear line, since it's a plane is a function of all the variables can be considered as output, and taking others, any variable can be considered as the output and others as inputs. So if you want to take x as the output, then solve for x, then you get x equals to 1 minus y minus z. But that doesn't change the plane, because plane is coming from the same equation. Is this good?
মিস, আমার কনফিউশন হচ্ছে মিস যে আমরা যেরকম z equals to 1 minus x minus y, এটা যে মিস রাইট সাইডের প্লেনটা আমরা চিন্তা করতেছি, তাহলে মিস x equals to 1 minus
no, it's not right side plane. It's not right side plane. This is this triangular shaped bluish plane, the triangular shaped bluish plane. Remember, this is a kind of a portion of a tetrahedron.
Okay, miss.
No, I shouldn't mention the word tetrahedron. It becomes even complicated. Suppose that you have a plane inclined to the z-axis in that way, and this plane is not limited to this portion, as I said, because you just see portion of the plane from the first octant. In the first octant, this much of this plane can be visible. Just go, this is a plane, this is the wall of your room, just go beyond that wall. This is a wall of your room, just go beyond that wall. No mamuni, this is not a pyramid. This is a plane can be considered in its rectangular shape. plane can be considered in rectangular shape, but for the portion of that rectangle, you see that one looks like a triangular. It looks like in triangular shape. You have a hollow. You have a hollow between this plane and the floor and this portion of the wall. You have a hollow. A tetrahedron. Huh?
Miss Z equals to 1 minus x minus y to miss negative values গুলোর জন্য হবে না, তাই না? মানে যদি আমরা
Why not?
beneath the wall এ যাইতাম বা মিস নিচে চলে যাইতাম, ওই প্লেন গুলো কি এই ইকুয়েশনটা এক্সপ্রেস করা হচ্ছে?
Let's say that x is 2, y is negative 2. Then what happens?
মিস y টা মিস ওই সাইডে হবে মিস এক্সটেন্ডেড পার্টে।
Then the portion is valid, right? Then portion is valid. Nowhere it is said that x, y, z all are positive or all are non-negative. X, y, z can be negative, but yeah, all three of them cannot be negative at the same time to add up to 1. All three of them cannot be negative at the same time. So there are few octants where it doesn't intersect. Definitely there is one octant. Definitely there is one octant where all three variables are negative, and this plane doesn't go to that octant. Do you understand that?
মানে মিস এটা এক্সটেন্ডেড পার্টের জন্য হবে, মানে ফুল সারফেসটা কি, মানে ফুল এটা মিস শেপটাই হচ্ছে ইকুয়েশন হচ্ছে যেটা লিখছেন আর কি।
Exactly. So this is a portion of the plane that you see from the first octant. Is that okay now? Class?
Yes, miss.
Similarly, see this portion. This is a bluish portion. As I said, just think that you have kept something in a way at the corner where there is a vacuum between the plane and the corner, and portion of the plane is looks like a triangle. Okay. If you keep some triangle at the corner of the room, then that you can extend that side of the triangle through the planes, horizontal plane and the vertical planes. Then that extension, the indefinite extension of that portion is the whole plane. Okay. In same manner, if you think of this thing, if x and y are 0, that means if you are on the z-axis, then x, y 0 and z is 3. If you are on the x-axis, y, z are 0, then x is 6. If you are on the y-axis, x and z 0 and y is 4. So that is how you get these 3 points, and join all those 3 points, then you see the portion of the plane. Is that good to everyone now?
Yes.
Yes.
Okay. So how long is the lecture today? 5:50, right?
Yes, miss.
Okay. So that I will show you the plane equations, and I will get back to you in 2 minutes. I'm taking break for 2 minutes. Okay. Oh. Is it okay to you now, class?
Yes, miss.
Hello, bakira ki korcho?
Yes, miss.
Yes, ma'am.
Okay. I think we have discussed this. Square root of 9 is just +3 and minus negative square root of 9 is -3. We have discussed this before we started finding domain, right?
Yes, miss.
Okay. So this definition is this definition has been already given to your class, and the definition of negative square root and positive square root, those definitions are not new to us, are they? Remember, did you study? So I'm not going to repeat this. I'm not going to repeat this. I'm just going to start the start graphing function. Is that good to everyone?
মিস আমার হোমওয়ার্কটা নিয়ে একটা কোশ্চেন ছিল।
Yeah. Please.
মিস ওটা কি আমরা ওই যে এভাবে সলভ করব যে একটা দুইটা 0 হলে আরেকটা মানে 2x + 0 4 * 0 এভাবে করে করে তিনটা ভ্যালু বের করে তারপরে দেখাবো যে x y z এর কোঅর্ডিনেট এইটা and then তারপর গ্রাফ।
Exactly. Yep. Exactly. See, this information, what does it mean? This information, first we have found the intersection. We have found x, y, and z intercepts. X-intercepts. This is the x-intercept, y-intercept, and z-intercept. That means these three are the points where the plane intersects x, y, and z axis respectively. And then we have seen these are the intersection between two planes is a line. I said it many times today. Okay, intersection. If you think of two planes and they're intersecting each other, then they intersect through a straight line, guys, right? So this is the line.
Yes,
this is the line which is the intersection between our given plane, between the given plane and the xy plane. This is the intersection. This is the intersection. This line is the intersection of the given plane with the YZ axis. And this is the intersection of the given plane with the XZ plane. Now, if you want to find, see, these are the XYZ intercepts. Do you remember y intercept, x intercept? Do you remember those definitions of a straight line when you studied?
Yes, miss.
Pre-calculus?
Origin থেকে distance টা miss.
Exactly. So this is the x-intercept, y-intercept, z-intercept. When you try to find intercepts, then those intercepts must be on axis. So if we take x and y both 0, that means you are talking about z-axis. So solve 4z equals to 12. 4z equals to 12 means z equals to 3. So here you go. On the z-axis, you have a single point. Okay, so this does not intersect the negative z-axis. Remember that. This plane does not intersect the negative z-axis. This plane intersects only the positive z-axis at the point 0, 0, 3. Again, this intersects only positive x-axis at the point 6, 0, 0. It intersects only the negative y-axis at the point 0, 0, 4. Okay.
Yes, miss.
Okay. So there you go. So then now the question is, what is the intersection between this plane? What is the intersection between this plane and the xy plane? If you want to talk about the xy plane, z must be 0. So then put it 0. Vanish this term. Then you have 2x plus 3y equals to 12. That means x-intercept is going to be 6, y-intercept is going to be 4. You already have those two intercepts. Just add those two intercepts to find the line, which is the straight line which falls on the xy plane, which is, do you see this border? This is the line on the xy plane. So this is the set of all common points which is on the xy plane. Is that good to you now?
Yes, miss.
Similarly, this line is the intersection between YZ plane and our given plane. And this line is the intersection between XZ plane and our given plane. Now the question is, this plane does not touch negative y-axis. This does not touch negative y-axis, but if we extend it, look at thing. If it goes beyond, then it go to the octant. It doesn't touch the negative y-axis, but it touched the octant where y may be negative. Do you understand that? Because if it cross this plane, then y becomes negative. Do you understand that? If this plane crosses zx plane, then y becomes negative. If it goes under this xy plane, then z becomes negative, though it does not intersect the z axis, though it does not touch the z axis, but it goes to the octant where z is negative. Similarly, if it crosses this plane, then x becomes negative. Is that good to everyone? But that portion you don't see.
Yes, miss.
That portion we don't see when you are sitting in the first octant. This is the portion that you see when you are in the first octant. So we are trying to sketch that portion only. Is that good to you?
Yes, miss.
So shall I continue to the next one?
Yes, miss.
And I think that should be the last one for today. Okay, so exercise. I'm not going to discuss this. As I said, you guys should read this and see if you have any questions from this part, because I have discussed all of this theory before I started finding domain of function of several variables, because you need this information. And I said many times that we need this later when we will be studying functions in details. So here you go. Look at the function. The number 4 is our next graph, which is given by the function of two variables f of x, y equals to this. Okay, so if I said this, since the notation of function of two variables, the most used notation, the common notation for the function of two variables is z equals to a function of x, y. That means we have z equals to square root of x square plus y square. Is that okay to everyone?
Yes, miss.
Now you just need to understand that since I have taught you how to find the domain, look at the equation. You have a square root, and inside the square root you have sum of two. You have sum of two squares. That means x and y can be anything. That means domain of this function is the whole xy plane. Do you understand that?
Yes, miss.
Class? Wake
Yes,
up, class. Please wake up. It's really not fun to teach when you are sleeping. Class, wake up. I'm supposed to have a huge section. I have 29 students, but I think many of them are sleeping. Only 2 of you or 3 of you are studying with me. Is that so?
No, miss.
No, ma'am.
See, I'm not teaching easy topic today, so you have to participate. Okay? In 10 minutes, I'm going to give you something to graph. So focus. Okay. So now we agree, we understand how we got there, right?
Yes, miss.
Okay, very good. Since is it positive square root or negative square root, by the way?
I'm positive.
Positive.
This is the positive square root because we don't have negative sign here. So definitely this is a positive square root. X and y can be anything. Did you understand that?
Yes, ma'am.
Even 0, x
Yes,
and y
ma'am.
both can be simultaneously 0 because square root of 0 is 0. That means since z is given by dakho, whatever we have studied so far is coming back now. Since z is given by a positive square root, z cannot be negative. Z is 0 only if x and y both are simultaneously 0. Otherwise, z must be positive. How big z can be? Infinity.
Infinity, yes, miss.
Since x and y can be anything, that means x and y values can be negative, close to negative infinity or close to positive infinity. It doesn't matter, because when we square them, we get positive. So z is greater or equal to 0. So the range of this function is all non-negative numbers, 0 and positive numbers. Range is one-dimensional. Remember, range is one-dimensional, but domain is two-dimensional for function of two variables. You got to be careful. Okay. Now let's go with the plane, guys. Let's go with the planes. So let's start with the xy plane. How much portion of this graph is on the xy plane? So if we work only on the xy plane, we take the projection by taking z equals to 0, since we are taking projection using an equation. If you use equation, then you use the equation of the plane. So z equals to 0 is the equation of the plane. So on the xy plane, you have this equals to 0. Squaring both sides, you get this. And since this is sum of square is 0, this is impossible. If x and y both are not 0, then it is impossible to get the sum 0. Is it clear to you guys?
Yes.
So if you consider the whole line, then what do you get? X equals to 0, y equals to 0, and z equals to 0 for the xy plane. That means xy plane contains only a single point of this graph. That means only the origin is the portion of the xy plane which belongs to this graph. Is that clear?
Yes, miss.
Very good. So let's move to the YZ plane. On the YZ plane, the equation of the YZ plane is x equals to 0. So let's take the projection of this equation on the YZ plane. Plug in x equals to 0. Then we have z equals to square root of y square. Z equals to square root of y square. And if we do the simplification, by definition, you get this is positive square root. This doesn't allow negative values, so z must be given by this absolute value of y. And if you think of the graph of the absolute value function, it is a v-shaped function. Vertex at the, I'm talking about only the xz plane. I'm talking about not xz, yz plane. If you think of a yz plane and compare it with the xz plane, remember on the xy plane, y equals to modulus of x. This is a v-shaped graph opening upward on the xy plane, and this one is symmetric about the y-axis, where y is the output. Remember, y is the output. That means in this function, when you are in yz plane, z is the output. So this will give us a v-shaped graph which is symmetric with respect to z-axis, and vertex will be at the point 0, 0, and it's opening upward. Are you able to compare them? Are you able to make the connection between those two information?
Yes, miss.
Class, do you find it difficult?
Miss, এটা V-shaped plane হবে, তাই না?
It's a V-shaped graph of it. It's not a plane. It's a graph.
So, okay, understand.
When you are in 2D, you have lines. So you have you have a curve that is V-shaped curve. Do you remember the absolute value function from the library of functions? It's a V, right?
Yes.
Yes, miss.
So similarly, if you only focus on xz plane, equation of xz plane is y equals to 0. So if you plug in y equals to 0 in this equation, then you get z equals to square root of x squared, which gives us z equals to modulus of x. That means this is a v. On the xz plane also we have a v. with vertex at the origin, opening upward, symmetric with respect to z-axis. Look, symmetric with respect to z-axis, symmetric with respect to z-axis. That means the informations are uniform. Uniform. This is not a clumsy graph. It's a very beautiful, nice graph. Whatever shape you have on the YZ plane, you have the same shape on the XZ plane. That means we can just spin it to get the whole solid, because we are in 3D. We are in 3 dimensions. So look at this thing now. So this is what you have on the XZ plane, a V with vertex at the origin. This is what you have on the XZ. This is on the XZ plane, this is on the YZ plane, it's the V. Now if you spin it, remember, if I now include in 3D, here x0, y0, here y0, z0. So if you combine them in the 3D space, then you have 0, 0, 0, which falls on the xy plane. Which falls on the xy plane. This is also portion of the graph, and we have seen that the xy plane contains only the origin from the graph. Is that good to everyone?
Yes, yes.
Now, if you spin one of the V, since you have similar pattern, so if you spin one of the V, then you get something like that. It's a cone. If you spin it, do you understand what I mean by spinning?
Yes.
So if you spin that V, then you get something. Let's say that this one, if you spin it, then it will move. It will rotate in circular motion. Then you get something of that kind. Look at this thing now. 0, 0, 0 is on the XY plane only. Doesn't matter which plane you consider. Even not only coordinate plane, think of any plane. Think of any plane that goes through the Z-axis. You will get a V on that plane that is symmetric about the Z-axis. That was a huge information for us as well. This is a V symmetric about the Z-axis. This is a V on the XZ plane symmetric about the X-axis. This is a V on the ZY plane symmetric about the Z-axis. The symmetric about the same line. That means you have if you spin it, by spinning you get a cone. This is the graph of the function, which is a cone opening upward. It's a cone opening upward with vertex at the origin, 0, 0, 0. And it is a hollow cone. When you have the function, it's a hollow cone. That means this is just the cone for the ice cream cone. Inside, you have nothing. Do you understand the shape of the graph?
Yes,
Yes, ma'am.
So this is in 3D image. This is how it looks like. Well, the height of the cone is infinity, since the range of the function is greater equals to 0. That means there is no upper bound. So it goes upward indefinitely. Do you understand that? Was it difficult to see the graph? And will you be able to graph it?
Yes, miss.
Class, are you good?
Yes, miss.
Yes, miss.
Okay. Last 10 minutes. I will give you a couple of examples. Then I will let you graph one of them. Okay. Guys, do you remember the transformation? If you know the graph of f of x, what I'm trying to say is that if we know the graph of the function, x equals to graph of, so y equals to f of x. Guys, help me. Huh? If we know the graph of the function y equals to f of x, okay, then so I will just write one by one. You are to give me the information, okay? So, then we get this. How do we get this?
Miss, it would be just the reflection of f of x.
Reflection.
I mean, it would be in the negative x, negative direction.
Reflection with respect to which axis?
Y-axis.
X-axis. X-axis, because x-axis, because you are changing the sign of y. Here y is f of x, here y is f of x, and here y is negative x. So if you have some value for this, whatever value you have here, you have opposite value here. That means y is changing sign, and y changes sign when you take the reflection about the x-axis. Are you good?
Yes, ma'am.
Yes.
Okay, good.
Yes, miss.
So how do you get this? Let me add something. Let's say that I'll make it easy for you. How do you get this?
On the right side of 2 units, right?
Raising
Right.
unit. And by shifting the graph to unit on the y-axis.
ভুলে গেছো সব?
2 units above x-axis.
No, two
Along
units,
y-axis.
actually 2 units upward. Upward, shifting the graph upward by 3 units. What about now? Oops. What about now?
Shifting the graph downwards.
Okay. Okay, good. Aru আছে? There are many more, right? The transformations. I will stop here since I have just 9 minutes. So guys, if I go with this, then what can you conclude about this graph? Compare with this.
Reflection about x-axis.
নিচের দিকে হবে মিস, নিচের দিকে মিস
Reflection about the
X-axis.
XY plane.
X-axis.
XY plane.
XY plane.
XY.
Right. XY plane. You are in 3D now, right? And what about this one?
Ma'am, the
Shifting
reflection
the
will
graph
be 4
upwards.
units upwards.
reflection about xy plane and 4 units above the
4 units along z-axis.
XY প্লেন থেকে 4 ইউনিটস উপরে হবে ম্যাম, কিন্তু উল্টা হবে, মানে নিচের দিকে হবে ডাইরেকশনটা।
Right? And what about this one?
1 unit along z-axis.
Don't do nothing, just shift 1 unit upward, right? All good?
Yes, ma'am.
Yes,
Do you
miss.
have a question? So I'll give you just 5 minutes to upload a problem. So graph this. I will edit. Let me copy. So number 8, submit number 8. Okay, please submit. I will take it minus and minus. As simple as that. Please upload it. I'll open the portal for you. Okay.
মিস আমাদের কি ফাইনাল ছবিটা আঁকলেই তো হবে তাই না?
Yep. Okay. What about others?
Ma'am,
Hmm?
in Google Classroom.
Yes, in Google Classroom. What? Sorry. Farzana? Farzana, are you talking to me? Okay, class. So let's start. Shall I?
Yes, miss.
Yes,
Okay.
miss.
Yes, miss.
So if you want to graph this function, we will start by graphing a function, since we ended there, right? The last function that we graphed, it was an exercise that you submitted, which was number 8. You submitted it. Not all of you, but many of you did. So now I'm going to continue with number 9, okay? So they are similar. Look at the graph. This is called goblet. So you had a cone for the other one, for the positive square root. Only one thing is missing here is the square root that you had in exercise 4. Okay? So if you set this function as z equals to x square plus y square, for obvious reason, the range of the function is non-negative real numbers, and the domain of the function is the whole xy plane. We are good, right, with that?
Yes, miss.
Yes, miss.
So if we look at the projection, if you take the projection on the xy plane, z equals to 0. So if you set z equals to 0 here, then you get x square plus y square equals to 0. Then obviously this will imply that x and y both are 0. That means the only point on the xy plane is the origin. And since z is greater or equals to 0, so the graph of this function, which will be a solid, that will be above the xy plane, where only the origin is on the xy plane. So let's see the shape of the graph on other two planes. So if you go with the yz plane, we know that equation of the yz plane is x equals to 0. So if you plug in x equals to 0 in this equation, then you get z equals to y square. If you recall,
মিস আপনি on the xy plane এ লিখছেন না যে z equals to 0, তাহলে x square plus y square equals to 0. তাহলে মিস তারপরে মিস x equals to y equals to 0 কেমনে হইলো?
If the sum of two square is 0, then what can we say about individual term? You are adding two numbers, and you are getting 0. And both of the numbers cannot be negative. They are non-negative numbers. The square cannot be negative. So you are adding two non-negative numbers and you are getting 0. If you add two positive numbers, you don't get 0. They cannot be negative. So the only way possible is that they are 0. That means x squared and y squared both are 0. And if x squared is 0, then x must be 0. If y squared is 0, then y must be 0. Only these two cannot be negative. Do you understand that? X squared cannot be negative, y squared cannot be negative.
Yes, miss.
So these two terms are non-negative terms. And if you add two positive numbers, you always get a positive number. But you are getting the sum 0. So since you are getting the sum 0, then obviously you are adding two zeros. Otherwise, this is not possible, right?
Yes, miss.
Okay. So here you go. Now on the yz plane, we have z equals to y square. So if you recall, y equals to x squared, you know that y squared equals to x squared is a parabola. So it is a U-shaped graph. Opening upward on the xy plane and symmetric about the y-axis, where y is the output. That means symmetric about the output axis এবং vertex is at the point 0, 0. So if you compare with that, So here we have output Z and input Y. So this will be a parabola, which is a U-shaped graph opening upward on the YZ plane. And this U should be symmetric with respect to the output axis. Output means with respect to the Z axis. And the vertex will be at the point where Y is 0 and Z is 0. And look at the equation of YZ plane, X is already 0. That means if you are in 3D, then vertex must be at the origin in 3D. Does it make sense?
Yes, miss.
Similarly, if you take the projection on the XZ plane by setting Y equals to 0, I am sorry. If you take the projection on the XZ plane by setting Y equals to 0, then you get setting Y equals to 0 in which equation? You remember that, right? Just set Y equals to 0 in the equation Z equals to X square plus Y square. Then you are left with the equation Z equals to X square. And this is a U-shaped graph, symmetric with respect to the Z axis. That means you see a similar uniform pattern on the YZ and ZX plane. On the YZ plane and the ZX plane, we have a similar pattern. So if you revolve now, since the graph is symmetric with respect to the Z axis, it's a U-shaped graph, symmetric with respect to the Z axis. Let me write it down. I will just copy it, okay? So it's a U-shaped graph. So here you go. It's a U-shaped graph opening upward on the XZ plane. On the XZ plane and symmetric about the Z axis. About the Z axis, I don't need this information anymore, so let's erase it. Vertex 0, 0. So now, if you revolve, since the curve is symmetric on the XZ plane, it is symmetric about the Z axis. So if you are on 3D, then Z is a vertical axis. So if you revolve the U-shaped graph around the Z axis, then you get something looking like this, which is called goblet, right?
Yes, miss.
Class, are you with me?
Yes, ma'am.
Yes,
This is the 3D version of the parabola, which is called paraboloid. So the graph of the function Z equals to X square plus Y square is a paraboloid, which is symmetric with respect to the output axis. Remember that here we have output Z, so it is symmetric with respect to the Z axis. If we have something like this, if you have something, let's say that, which one I'm going to say? I'm going to say that X equals to Y square plus Z square. If I write it like that, if you have something like this, this is going to be a paraboloid. Huh? This is going to be a paraboloid. I will use the word paraboloid. Now you know the shape of a paraboloid. Okay. Now you know, actually let me type, okay? Let me type. It's a paraboloid. It's a paraboloid. Symmetric about the which axis? What is the output, by the way? Right now, what is the output for the new equation?
X is out.
X is the output, so it should be symmetric about the x-axis.
X-axis.
Yep, with vertex at the since we name it paraboloid, that means we are in 3D. We didn't call it parabola. We are in 3D because we called it paraboloid. So with the vertex at the origin, okay, and opening and opening, because we have two different portion of x-axis, so opening towards the positive, x-axis.
X.
Can you graph that one then? Is it difficult to graph for us?
মিস তাহলে তো ওইটা xz প্লেনও পড়তেছে xy প্লেনও পড়তেছে তাই না?
Definitely, because the domain of the paraboloid is the whole yz plane. The domain of the paraboloid is whole yz plane. So you have a parabola shape on the xy plane, you have a parabola shape on the xz plane.
তার মানে যেটা ডোমেন থাকে ওই সাইডে আর ফিগারটা মানে এটা থাকে না তাই না? আই মিন মিস গ্রাফটা যেরকম যখন আমরা ড্র করতেছি তখন তো এটা xz প্লেন আর xy প্লেনে থাকতেছে। তো মিস আপনি বললেন না যে
it's spreaded over the domain. It's spreaded over the domain, which is the whole plane, but the graph shares only a single point on the plane, which is the domain. That means origin is the plane which is on the domain. When you are talking about domain, you have a 2D plane, okay? You have a 2D plane, but when you are graphing the function, you are in 3D. So when you are in 3D, the domain contains only a single point of the graph. Okay? Did you get my point? Hopefully I will be able to graph something. I'm not so much confident, because since I'm going to insert something, I'm really not very much confident about this. Let me try. Oops. Not like that. Did I take a straight line? I want to take the curved line. I meant it, but which one did come?
মিস তার পাশে আরেকটা ছিল মিস ওইটা মনে হয়।
This is also supposed to work. Okay, let me try with the other one then. Okay. Oof, this one is not going to work. I have to take two of them, I guess. See, this is not the one. This is definitely not the one. Other one is the right one. Let me try for the last time. Otherwise, you have paper and pen, you will complete the graph. Okay. I think good enough. Okay, wonderful. So let me extend this line. Perfect. Now I have to make sure that the revolving portion is clearly seen, right? So let me make that thing clear. I think I made the mistake. I know what I did. I know what I did. This portion is definitely not difficult. So actually it should be in that way. Okay. More or less okay. At least, since I'm trying to graph inserting shape, I think this is okay. I didn't mean the outline. Oof. Sometimes it's really okay. I wanted to change the fill. Fill should be empty. No fill. So here you go. Do you see the paraboloid somehow?
Yes, miss.
So do you understand what it means? So class, next thing is that, let's try to see the transformation of this paraboloid. Let's see the transformation of this paraboloid. So homework portion that you are supposed to graph at home. Here you go. So here you go. This one is something. Do I have to tell you what we have here?
No.
No, ma'am.
So if you copy that one, hopefully I will be able to copy. So this one is reflection about which plane, by the way?
Z-axis. Oh.
This one is reflection about the which
ZY
plane? XY plane. The domain is XY. So this is the reflection about the XY plane. So if we extend the Z-axis portion, okay, let me use a dotted axis so that we see it. So let's say that we have a extension of the Z-axis, not straight, kind of. Okay, let's take it. Okay, let's take it. So we will use the dashed line for that thing. Let's say that this one. Okay, so then we have. If you take that one, so let's revolve it a bit. Okay. So let's move it for our sake. So there you go. So let's take the circle as well. First rotate it a bit. Okay. Then move it. There. So this is the graph of the you understand what it means, right? So this is the reflection about the XY plane. For example, if I extend the y-axis, it must go under the y-axis. Do you have question on that?
No, ma'am.
So there you go. Okay. So now, then I will take answers from you. The origin is the vertex for this paraboloid as well. But for this one, can you tell me the paraboloid of vertex of this paraboloid? Did I hear it?
মিস একটা কোশ্চেন ছিল মিস আমরা যে আজকে প্রথমটা করছিলাম মিস x স্কয়ার প্লাস y স্কয়ার রাইট ইকুয়ালস টু 0 মিস পরের ইকুয়েশন কি ছিল মিস মানে সেকেন্ড যেটা করলাম হ্যাঁ মিস নিচে
No, your first function was f of xy equals to x square plus y square. This is the function you are graphing.
হ্যাঁ 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 মিস আর পরেরটা
Next one was the function, which is a function. This one can be denoted as, this one is function of yz. This is the function, which is function of yz. So x must be the output. So I'm back to exercise 9, because this is reflection of the paraboloid which you got in exercise 9. This is the reflection of the paraboloid which is symmetric about this one, reflection of this one. Symmetric about the z-axis, opening up.
About z-axis.
Of course, because we have the in here. Look at the function. This is a function of x and y. So z should be the output, right?
Yes, miss.
So xy plane is the domain. So output should be the z-axis. The range should be the z-axis. Over here we have the range, which is non-negative portion of the z-axis. Z cannot be. I'm sorry, non-positive portion of the z-axis. Here z cannot be positive. Z must be less than or equal to 0. Making sense to everyone?
Yes, ma'am.
Ma'am, the upward arrow is Z, and the reflection is minus Z, right?
Of course, because we have seen that we have studied that Z is the vertical axis. Z is the vertical axis, and the portion of the Z which is above the XY plane, that is positive portion of the Z axis. Z axis has a common point, a single point which is common with the XY plane, and the portion of the Z axis which is under the XY plane, that means below the XY plane, that portion is negative Z axis. So this portion is positive Z axis, this portion is negative Z axis, and this is the origin, which is the intersection of the Z axis with the XY plane.
Okay, thank you, ma'am.
You are most welcome. Did you miss the last class?
No, ma'am. I just want to be sure.
Okay, very good, very good. So did I hear your answer when I asked you what is the vertex of this paraboloid?
004.
004. What is the vertex for the exercise 12?
0, 0, -1.
0, 0, -1.
Why do you think
0,
minus
0,
1? Can you please tell me how did you get? Can you please tell me how do you get this if you know the paraboloid? Let's say that if you know the graph, if you know the graph of, let's say that Z equals to, graph of Z equals to this. Then how do you get there? How do you get there?
Reflection along XY axis plane and then 4 units upward.
So reflection, first you take the reflection about the XY plane, and then 4 units, shifting 4 units upward. So if you take the reflection, look at the graph, we have already seen the reflection. Reflection about the XY plane does not change the vertex, because vertex is origin which is on the XY plane. So it stays at the same point. So the vertex of this one and the reflection is same. But then adding 4 to Z means you are taking it upward 4 units. So the vertex goes up 4 units, so it becomes 004. What about this one? How do you get this?
Only 1 unit upward.
So 1 unit upward. So why a couple of you were suggesting the vertex to be 0, 0, -1?
No, ma'am, positive 1. 0, 0.
Positive 1. So the confusion is clear, right?
Yes, ma'am.
Okay, very good. So I believe you will be able to see. Plus, there are, yep.
মিস আমার একটা কোশ্চেন ছিল, সেটা হচ্ছে মিস এখানে x² + y² আমাদের ফাংশনটা না মিস, এখানে যদি আমরা এরকম দিতাম যে 4x² + 4y²,
does not make any difference. It will be wider. The parabola will be wider a bit. Do you remember transformation, horizontal stress, horizontal compress? So this will be horizontally stressed. I'm sorry, this will be vertically stressed. This will be vertically stressed because so note that the graph of this, I'm factoring out 4. The equation you gave me 4x² + 4y², I'm factoring out 4. So this is note that the graph of this is vertically stressed graph of the graph this. Because for the same input, whatever input you have here, this function has class. Do you follow me?
Yes, miss.
Yes, miss.
This function has domain all the whole xy plane. This function also has domain the whole xy plane. Whatever point you take from the domain from the xy plane, whatever point you choose, let me denote it this. So the value of z1 is 1/4 of value of z2. That means value of z1 is 4 times value of z2 is 4 times value of z1. Look at this thing. This is the z1. This is z1, right? This is z1. So this
Yes, miss.
z2 is 4 times z1. So if you take 0, 0, z is 0. If you take 1, 1, z1 is 2, z1 is 2, z2 is 8. So that means it's tracing vertically. Did it make sense?
Yes, miss.
Okay. Okay then. But class, if you change the coefficient for x and y, if the coefficients of x and y are different, then you have a ellipsoid. You do not have actually with the with the square root, ellipsoid even a bit different, but well, we'll talk about that later, because ellipsoid has different equations. Okay, ellipsoid has different equations. For example, x square plus y square plus z square equals to sphere. Sphere is given by x square plus y square plus z square. Look at the coefficient of x, y, z. Look at the coefficients of x, y, z. All the terms have coefficient 1, right? Coefficient 1. If we get different coefficient in this equation, then it is ellipsoid. Okay? This is ellipsoid. This is ellipsoid. This is ellipsoid. Did it make sense to you? So if you solve this for z, whatever you get, that will be portion of the ellipsoid. Okay. So we will see this eventually. Now, what I was suggesting you that there are there are 4 or 5 exercises which are assigned, which are given in the list of practice exercises where you are supposed to graph the functions. Please try them. Except one, all of them are quite visible on the paper, on 2D. One may not be visible. One of them is not that clean to see on paper and pen, because if you see the 3D graph, then it will be more clear to you. But I don't want to mention which one. You are to find that out. You are to find that out, so that you at least you realize when we fail to see it clearly. Okay? Did you understand my point?
Yes.
Yes, miss.
Yes, ma'am.
Okay then. So I will leave this questions and answers session. This is from last semester. I could erase all of this, but these are very good questions, so I saved it for you guys. Just go through. These are the questions. Sketch the domain of the function, which is the domain is found here. Domain is found here. So you are to complete the question. So what should be the domain? The sketch of the domain I meant. Okay. The same for the other one, I believe. Okay. They are close to each other, so that is the reason they works together. They came together. So I think it's a very good start. If you practice.
Q&A থেকে একটা কোশ্চেন ছিল।
Which one?
কিছু যে ফার্স্ট এর ln xy এটার গ্রাফটা না আমি সলিউশনে দেখলাম শুধু ফার্স্ট কোয়াড্র্যান্ট আর থার্ড কোয়াড্র্যান্টে শেড করেছে, এই পার্টটা আমি বুঝিনি।
Did you understand this portion? Did you understand this portion? Because for the domain of the function xy must be this is the domain of the function. The function of natural log is set of positive numbers. The function of natural log or any log, the set of logarithmic functions is set of positive number. So whatever you have here as input, whatever kind of equation you have as an input, that equation cannot cannot give us any zero or negative value. So that equation should give us positive values. Positive means greater, so xy must be greater than 0. So if product of two real numbers, if the product of two real numbers is positive, then either both are positive or both are negative. So that is what it is written here. And first quadrant means both are positive, third quadrant means both are negative. So you don't have the axis portion. You don't have the axis portion. We don't have the axis portion. You have to think critically. That is the reason I left it incomplete for you, class. So for the domain is two-dimensional, since the function is function of two variables. So domain is two-dimensional. That means domain is portion of the xy plane, and on that plane we don't have axis included in the domain. So y-axis is excluded from the domain. Y-axis is excluded from the domain. The x-axis excluded as well. The x-axis also excluded from the domain. So there should be dotted line. Now we take the portion of the plane. Now we have distinct four quadrants. That the quadrant portion minus axis. So from those four portions, you take those two portions where x and y both are positive, or x and y both are negative. So it gives you the first quadrant and the third quadrant. Did it make sense now?
Yes, miss.
Class, you're good? So
Yes.
this picture is not complete yet. I'm not able to shade the portion first quadrant and the third quadrant. Could you please do this on your notebook? Just shade this portion. Y-axis, dotted y-axis, dashed y-axis means it's excluded, dashed x-axis means it's excluded. Now you have portion of first quadrant and you have third quadrant. Just shade the first quadrant and third quadrant. What should be that means first quadrant and the third quadrant. If you take the union, then those two portions will be the domain of this function. And interestingly, for this one, you have the axis included. Since they are similar, that is the reason they works together. Because now you have positive.
Miss, আপনি বলেন না যে y greater than 0 তখন x greater than 0 অথবা y less than 0 and x less than 0 মিস, এটা কি এই কারণে যাতে করে মিস নেগেটিভ আর নেগেটিভ আর পজিটিভ হয়?
Of course, when do we get positive from product of two real numbers? If you have positive product of two real numbers, when you have product of two real numbers positive, then either you are multiplying two positive numbers or you are multiplying two negative numbers, so that negative and negative make it a positive number, right? So obviously that is the fact. Are you clear then?
Yes, miss.
Okay. So now the next topic of the section is level curves and level surface. When you have function of two variables, then you have the graph of the function will be a three-dimensional object, which is a solid, right? Plus?
Yes, miss.
And we know that z equals to constant. If we write z equals to k, for example, If you write z equals to k, then z equals to k is a horizontal plane. This is a horizontal plane that is perpendicular to the z axis at the point 0, 0, k. You remember that, right? The last lecture portion. So z equals to k is an equation of a horizontal plane. So the level curves are the set of intersections which we get when a horizontal plane intersects or cuts the graph of this function. And we take the projection of that. The level curves are curved in 2D. When you have function of two variables, then you get it in 2D, because that means you take the set of intersection and then you take the projection on the xy plane if the domain is subset of xy plane. Then what does we understand by this constant k? So if you think of 3D, that portion, when you think of the level curve on the as a portion of the solid, then you see that shape at the height k. Look at the picture. Look at the picture. This is the solid that we have. So we are cutting this solid by the horizontal plane, which is given by z equals to c. So see the curve around which is the intersection, the common portion of the solid of the surface given by z equals to f of x, y, and the plane z equals to c. So if you take the projection of this curve, then you get identical curve on the xy plane. So this is the level curve. So now the question is, if you want to imagine this level curve as the portion of the surface z equals to f of x, y, then you lift this curve at the height c. Do you understand that?
Yes, ma'am.
So here is the definition. If the surface z equals to f of x, y is cut by a horizontal plane z equals to k, then at all the points on the intersection, we have f of x, y equals to k. Because here z equals to f of x, y and there z equals to k. So you can combine those two equations to get f of x, y equals to k. And the projection of these intersection onto the xy plane is called the level curve of height k, or the level curve with constant k. The set of all level curves of the function is called the contour plot or contour map of the given function. Contour plot means, let me show you the next picture. For example, let's say that you have the cone. Let's say that you have the cone. So if you set it equals to k, so this is giving us the level curves, right? So for the values k equals to 0, 1, 2, 3, 4, if you plug in k equals to 0, then obviously we are going to get only the origin. That means the origin in 3D and origin in 2D as well. Because 0, 0, 0, if you project the 3-dimensional origin, you get the 2-dimensional origin, right? So you get 0, 0. So if you take k equals to 1, remember z and k are equal. So if you take k equals to 1, by squaring both sides, you get the circle. Because if you square both sides of this equation, then you get x squared plus y squared equals to k squared. So if k is 1, then you get the circle with center at the origin and radius 1. If k equals to 5, then you get the circle with center at the origin and radius 5. So here you go. K equals to 0 is the origin. K equals to 1, 2, 3, 4, 5. Now the question is, these are the level curves. Now the question is, how do you see them? How do you see them on the cone? So origin at the height 0. That means origin must be on the xy plane, which is 0, 0, 0 in 3D. Okay? So now, with k equals to 1, think of this circle at a height 1. That means this one is the level curve with k equals to 1. Class, can you follow me?
Yes, miss.
Yes, ma'am.
So if you go with
Yes,
k equals to 2, so in 2D, k equals to 2, this is the level curve. This is the level curve. So if you see it on the cone at the height 2, so this is the circle at height 2. So height 3, 4, and 5. So if you have infinitely many of them, if you can take all possible level curves and see them, all the level curves actually give you a frame for the cone. And that frame is called contour map of the function.
We say circles গুলোর যে height গুলো এটার সাথে কি radius গুলোও same?
Obviously because of the equation of the function, not necessarily it will be same for each and every function, but for the cone, yes it is, because this is you have this equation. If we square it, the radius of each circle is k. So whatever value you have for k, you get the radius. K cannot be negative for the cone, because k is the z. K is the constant which gives you the horizontal plane. So if z is negative, then the horizontal plane does not intersect the cone. So k must be non-negative. And yes, k gives you the radius of the circle because of this equation, which is not always true, okay? Cone is very special function. Okay, so you have other definition, which is called level surface. Curve is 2-dimensional, surface is 3-dimensional. So when you have a function of 3 variables, and if this horizontal, I shouldn't say horizontal plane, if this surface, I should say, I shouldn't say horizontal here, because we don't know exactly, we don't have enough knowledge of 4D space, right? Then the intersection is given at any point at the intersection. We have this equation, and if you take the projection on the XYZ space, then you will get a 3D object, and that object gives us the level surface. For example, if you have this one, and if you intersect it with the equation W equals to 1, then you get the level surface is going to be this. So if you do the simplification, z is going to be this, which is the paraboloid, which is shifted 1 unit downwards. That means the paraboloid, which is symmetric with respect to z axis, opening upward with vertex 0, 0, -1. Did it make sense to you?
Yes, miss.
Okay, so this is understanding of level curve and level surface. Please practice few exercises so that the concept is clear. Otherwise, we will meet at the discussion session. Okay. So there are few. This is number 13. This is number 13, where we want to graph. We know the graph of this function. I think we know the graph of this function, right? Oh no, actually, guys, I don't want to explain this. Everything is written here. Just give it a thought. After that, we'll discuss this. Okay. I haven't discussed this. These are interesting. This graph is very interesting. Let me put a star on it. Okay. Oops. And so just putting a star is so difficult. God, how many attempts do I have to take? So it's their homework, I would say. Okay. I should say read this and try to understand, of course. If you have question, I am always there. Fair?
মিস এখানে কে এর কনসেপ্ট কেন আসতেছে? এখানে তো লেভেল সারফেস অথবা ওগুলোর কথা তো কিছু বলা নেই। মানে আমরা যখন মিস কিছুক্ষণ আগে একটা ফাংশন করলাম, ফর এক্সাম্পল এফ অফ এক্স ওয়াই ইকুয়ালস টু এক্স স্কোয়ার প্লাস ওয়াই স্কোয়ার, ওইখানে তো মিস আমরা ডিরেক্টলি ফিগার আঁকছি না, মানে ডোমেন সেট বের করে। তো মিস এইখানে কেন এই যে কে এর কনসেপ্টটা আনতেছি?
You do need for example, if you are talking of 2-dimensional or 3-dimensional, you need to know level surface. Do you remember how did you learn to graph the map of Bangladesh for the first time?
Yes, miss.
Did you make few boxes, few squares, and then learn it by portion, which
Yes, ma'am.
portion goes in which square? It's a similar
Yes,
concept. It's a similar concept. When the solid is not that clear, then level curves help us to do so. Help us to imagine the solid.
মিস তার মানে ফাংশনটা ডিফারেন্ট ওই জন্য আমরা অন্য প্রসেস ফলো করতেছি।
Not really. I gave you the example which we have already graphed, right? I gave you the example with the cone, and I have shown you how to graph the cone, right? So now it's a better view. Now it's a better view. I told you to revolve around the z-axis, and now I can tell you that yes, I was doing it correctly with the help of level curves. So even it is easy to read it, easy to see it, right? I said revolve the V around the z-axis, and we did it, and we found the cone, right? Did I give you more details than this? I didn't, right? And you trusted me. So now I have the proof that I didn't lie to you. We do have circle around the z-axis, so we need to revolve it. Okay, so it's a better view. Visualization is even much clearer with the level curve, right? So I will leave this to you, because see, look at the function number 13. It is easy to understand with the level curves. There are a couple of graphs and notes also there. You need to understand. I will just make two notes. Number one is that you see the circles here as well. You see circles around the z-axis here as well. But this is not like the cone. This is not like the cone, because if you go with this, and if you go with according to the plane says that you have a function which is the square root function. So this function and -1 means let's say the square root of -1. You're subtracting -1. That means something similar to this. Something similar to this. That means it's kind of like mic. Okay, that means it's concave down. The half parabola concave down on both ways. So that means when you have the circles and you want to join those level curves, if you want to join those level curves, then you don't join them like concave, like using the curve which is concave upward. You have to add them with the curve which is concave downward. Okay, this is all for today. The remaining is on you. Just spend some time on it. Okay, exercise for your brain. So it's a different number 13. I don't know why I have two 13s. Oh, okay. Since I have edited the other one, so it got messed up. So this is supposed to be 14. Okay. There you go. I'll leave it to you. So shall I continue the next section? Limits and continuity. Class, are you ready?
Yes, ma'am.
Okay.
Yes, miss.
So let me turn off the recording, and then